Hi everyone, welcome to Minute Puzzles. Today we'll be looking at two brilliant physics problems found from a recent Bollywood movie. We will be doing many interesting physics, maths, and logical reasoning puzzles on this channel. So do subscribe to the channel and hit that bell icon to get notified whenever we put up new puzzles. Here is the first problem.
अगर ट्रेन 120 मील पर आवर पर चल रहा है और एक-एक करके हम उसका डब्बा निकालते रहें तो अकेला इंजन कितना स्पीड पर चलेगा?
Simply put, the question being asked here is, a train going at a constant speed of 120 miles per hour, if we start detaching its coaches from behind one by one, what will happen to the speed of the train? The three options we have are A. The speed will remain the same. B. The speed of the train will increase. C. There is insufficient information to solve the problem. If you want to think about this puzzle and give it a try, pause the video here and resume to learn the answer. This is an interesting example of the law of conservation of momentum. The law states that if there is no external force applied on a system, the net momentum of the system is conserved. Here is a diagram of the train, the red car being the engine. Initially, all the cars are moving at the constant speed of 120 miles per hour. The momentum is represented by the product of mass and velocity of the body. So we can write the initial momentum of the system as m of engine plus m of car 1 plus m of car 2, which is all the same. So we put it down as n times the mass of the coaches or the car times the velocity, which is 120 miles per hour. Now, after the event, let's say we detach the last coach from the train. As there is no external force being applied to it, the last coach will keep moving in the direction of train at 120 miles per hour. It will not be attached to the train, but it will still be going with the same speed. Hence, we can write the new momentum as m of engine plus n minus 1 times m of car into v plus the m of the last car into v. And we can keep doing this, extending it to every car. As we start detaching the coaches, the net momentum of the system will be conserved and the train will still keep moving at 120 miles per hour. So, the correct answer is option A. The speed will remain the same. Now, let us consider another problem from the same movie which is slightly more complex.
अगर शोएब अख्तर 143 किलोमीटर पर आवर के स्पीड पर बॉल फेंके और बाउंड्री 63 मीटर दूर है तो सचिन तेंदुलकर को कितने फोर्स से बल्ले को घुमाना पड़ेगा ताकि छक्का लगे? हैं? सोचो.
Simply put, this question says, if a bowler bowls at 143 kilometers per hour and the boundary is 63 meters away, with what minimum force should the batsman hit the ball so that it goes for a 6? Now, there are some unknowns in this question, and to simplify things for us a little bit, we'll be using these three assumptions. First, the shot is played in the same plane as it is bowled. So, it is a projectile motion in one plane. All the motion is just happening in one plane. Second, the time of contact between ball and the bat is 1 second. Ideally, when the ball hits the bat, it is a very quick action. It imparts an impulse. But since we are asked to calculate the force, we will have to assume the amount of time the ball was in contact with the bat. And third, the ball hits the bat parallel to the ground. That is, the ball has no velocity in the vertical direction when it impacts the bat. Using these three assumptions, we will try to solve the problem. If you want to think about this puzzle and give it a try, pause the video here and resume to learn the answer. We are going to solve this problem using Newton's second law of motion, which states force equals to change of momentum with change of time. That is, force is equal to dmv by dt. Here I have constructed a diagram of the shot play. The purple dotted line is the ball being bowled, and the red projectile trajectory is its path to the boundary, which is 63 meters away. The batsman hits it with the velocity u, making an angle alpha with the ground. For the force to be minimum, the velocity u needs to be minimum, which happens when the angle alpha is 45 degrees. So let us suppose that t is the time taken for the ball to reach the boundary. And by this assumption, we can assume that t by 2 is the time it takes to reach its highest point, which is at the peak of the trajectory. Using kinematics, we are going to resolve the motion in x and y directions to solve this problem. In the horizontal direction, that is the x direction, we have u cos alpha times t is equal to 63. From here, replacing alpha equals 45 degrees, we get a relationship between u and t, that is u times t equals 89.09. And in the vertical direction, that is the y direction, we use the kinematic equation v is equal to u plus at. V at the highest point will be 0, and it will still be pulled down by gravity in the negative y direction with the gravitational force of g, that is 9.8 meter per second square. So we write the equation as 0 equals to the initial velocity in the y direction, that is u sine alpha, minus g into t by 2, because t by 2 is the time when it will be at the highest point. U sine alpha equals 4.9 times t, and from here we have another relationship between u and t. Now, using the two highlighted equations, we can substitute the value of t and find the value of u. Solving them, we get u equals 24.84 meter per second. Just to write them in terms of the x and y components, we'll write ux equals minus 17.56 meter per second as it is in the negative x direction, and uy equals to 17.56 meter per second. Now we know that the ball was bowled at the speed of 143 kilometers per hour, that is 39.72 meters per second in the x direction, and we're not going to assume it had any y velocity. So Vy is equal to 0 meter per second as per our third assumption. So applying the Newton's second law, force in the x direction equals the change of momentum in the x direction divided by delta t, and force in the y direction is change in momentum in the y direction divided by delta t. Delta t here we have assumed to be 1 second. So force in x direction comes out to be minus 57.28 times mass of the ball. Force in y direction is 17.56 times the mass of the ball. We calculate the net force by vectorially adding fx and fy, that is under root fx square plus fy square, and hence the total force is 59.91 times the mass of the ball, m newtons. So, how did you like these puzzles? To get more of these puzzles come up on your YouTube feed, do subscribe to this channel. Like and share this video with your friends and see if they can solve these puzzles. Thank you, and we will be back with more interesting minute puzzles.